What if the universe isn't just filled with shapes, but is itself a shape, written in the language of pure geometry? Not the triangles and circles from school, but wild high-dimensional forms that exist beyond our senses. For 100 years, physics has been split in two: general relativity, which choreographs the cosmic ballet of galaxies, and quantum mechanics, which governs the bizarre world of the tiny. Both are brilliant, but they refuse to speak the same language. Now imagine if both are just shadows, projections, of a single hidden geometric object. What if the answer to the universe's deepest mysteries is not an equation, but a shape waiting to be discovered? For centuries we've asked, what is the shape of everything? Telescopes let us map the cosmic web, while particle accelerators smash matter to reveal its tiniest secrets. Each journey led to astonishing discoveries, and a wall, the universe of the very large and the universe of the very small, seem to speak in rival codes, their equations refusing to meet. But what if that wall is an illusion? What if, at the deepest level, the universe is a single, breathtaking geometric structure, one that unites the stars and the atoms in a way no one expected? Now, a radical idea is emerging. The universe can be described as a network of shapes, where every interaction is just the shadow of a deeper, simpler reality. Instead of wrestling with endless equations, imagine if the answer to a complex physics question, like what happens when particles collide, was simply the volume of a particular geometric object. This isn't just a shortcut. It's a new way of seeing reality, where the chaos of the quantum world and the order of the cosmos are both encoded in the same elegant geometry. The universe, it turns out, might be far simpler and far stranger than we ever dreamed. Imagine physics not as a jungle of equations, but as a map of perfect forms. This isn't just a new tool, it's a revolution in perspective. It suggests that space and time themselves might not be fundamental but emerge from a timeless crystalline geometry. What if our universe is just one shimmering facet of an eternal mathematical jewel? The next time you look up at the night sky, remember, you might be gazing at the shadow of a shape more real than anything you can see. Imagine a universe where every event, from the collision of galaxies to the flicker of a single photon, is encoded in the facets of a geometric object. For decades, scientists wrestled with endless equations, each more complex than the last. But now, a breakthrough. What if the answer to every physical process is hidden in the shape itself? This is the first peak, a revelation that geometry can replace the mountain of calculations, transforming chaos into clarity. Instead of adding up thousands of terms, we now look for the volume of a single, elegant shape in a strange mathematical space. The probability of an event is no longer a tangled web of numbers, it's the size of a geometric form. One calculation, one answer, one leap forward. But the real jolt comes when we realize this method doesn't just work for the tiniest particles. It unlocks the secrets of the universe's birth, the very first light after the Big Bang. The cosmic microwave background, the afterglow of creation, is a code written in geometry. This is the second peak. With this approach, we can read the universe's origin story, connecting the quantum realm directly to the cosmos. Suddenly, the impossible becomes possible. These shapes are born from deep mathematical rules, polynomials, symmetries, and relationships that define entire spaces. In this world of positive geometry, the laws of physics are built into the very structure of the shapes. Instead of solving every equation, we explore the master shape that holds all the answers, a key to nature's secrets. And here's the third peak. This radical idea suggests that space and time themselves are not fundamental. They emerge from a deeper, timeless geometric reality. The universe, at its core, is far simpler and more beautiful than we ever imagined. We stand at the edge of a new era, where understanding shapes means unlocking the very code of existence. Imagine holding the universe's blueprint in your hands, not a stack of equations, but a single, perfect shape. This is the promise of the geometric revolution, a new way to see, to calculate, and to wonder. For a century, physics has been split in two: quantum mechanics for the tiny, general relativity for the vast. But what if this division is an illusion? Imagine a single, elegant geometry that unites the dance of galaxies and the flicker of particles. This new vision doesn't just bridge a gap, it shatters the wall between the very large and the very small. At its core, the universe may not distinguish between a particle and a galaxy. The same mathematical shapes that govern subatomic collisions could be sculpting the cosmic web itself. If true, this is the first step toward a theory of everything. Now, picture the universe as a grand library, not of books but of pure, jewel-like shapes. Each geometric form encodes the story of a physical process. To predict what happens when two particles collide, you don't solve endless equations, you measure the volume of a single dazzling object. This principle could explain everything from the bending of starlight to the birth of the first stars. The same geometric language written across all scales may be the true script of reality. What if the answers to the universe's mysteries are hidden in the facets of these shapes, waiting to be revealed? We stand at the edge of a new cosmos, just beginning to decipher this hidden library. The shapes are so complex, they exist in dimensions beyond our imagination. Here, the next scientific revolution is brewing, where physics, mathematics, and artificial intelligence converge. As our computational power grows, AI becomes our guide, searching for new geometries that could unlock the secrets of dark matter or reveal what happens at the heart of a black hole. The next breakthrough may not come from a telescope or a particle accelerator, but from the discovery of a shape that changes everything. Ultimately, this journey leads to the biggest question of all: what is the master shape of space-time itself? By understanding its properties, we might finally learn if the universe is finite or infinite, a fleeting moment or part of an endless cycle. The answer may not be found in particles or forces, but in the silent, eternal beauty of pure form. If we can grasp this ultimate geometry, we may glimpse the true shape of reality and our place within it. Imagine the universe not as a collection of separate things, but as a single, breathtaking shape, an intricate tapestry where every galaxy, every particle, and every moment is woven together. This is the first great realization. Reality itself may be geometry, endlessly connected and alive. If this is true, then to study geometry is to peer into the universe's own blueprint. Every new shape we discover is a window into the structure of existence, a key to unlocking mysteries that numbers alone could never reveal. This is the second peak. The shapes we find are the universe revealing itself to us. The more shapes we understand, the more of the universe's story we can tell. Perhaps in the end, the greatest secret is this: to know the shape of reality is to know ourselves, because we too are part of that